This video presents our CHI2023 paper titled Design Learning Understanding Information Needs for Model Transparency to Support AI Design Ideation. This work is situated in growing HCI research studying challenges that UX practitioners face when working with AI technology as a design material and how to better support their work. Among other challenges, designers need to understand this complex technology. A designerly understanding is not necessarily a deep technical understanding, but being able to link a technology's capability and limitations to what values it can deliver to users. This understanding of limitations is especially important for responsible AI practice, that is developing AI-powered application that is ethical and minimizing potential harms. Meanwhile, we recognize that supporting understanding of AI has long been the goal of the research area of AI transparency. Among other things, this area produces various transparency framework for model, data, and AI services. That is, what information about them should be communicated to stakeholders. And these frameworks are widely adopted in the industry through documentation features such as model cards, transparency note, and datasheet. In this study, we aim to bridge these two areas of work and explore opportunities and gaps for transparency model reporting framework to support designers to understand model. We explore this in the context of pre-trained models, which may broadly encompass AI services, model marketplace, as well as recently developed large pre-trained models. As a significantly reduced barrier to use AI capability, understanding them could serve as a first step toward enabling designer to use pre-trained model as a toolbox of a design material. We know that these surveys are currently not targeting designers and often assume direct users are ML or software engineer. But this is a problematic assumption, as engineers may not be best positioned to ideate on how to use a pre-trained model for a given application. And we emphasize responsible ideation, that one must responsibly decide whether, where, and how to use a model properly for real user needs with minimized harms to users. So this study also serves as a need-finding study toward enabling designer to perform responsible ideation and play a more central role in RAI practice. More specifically, you ask the following research question. First, what are UX practitioners' needs and challenges in working with pre-trained models? Second, to what extent are current model transparency framework useful for ideation? And lastly, what are the goals that designers seek model understanding for and how to support them? We conducted an interview study with 23 UX practitioners. After discussing their own experience with AI design, we introduced a scenario-based design task. We asked them to put on the hat of a designer working for a microblogging platform, and they're aware of this user problem of people sharing articles without reading them. The company purchased an AI service, including a pre-trained summarization model. Their task is to come up with a new feature of this platform that can utilize this model to tackle this sharing without reading problem. Participants were first given a model documentation created based on transparency framework. And then they could browse input-output example from the Playground UI, which is a very common feature of service providing pre-trained models. Then they were asked to ideate on this new feature. The study also included 2 iterations of their design idea, including reading a list of potential harms that can result from summarization models. Here, I focus on presenting results from the design task, where more discussion around participants' own experience working with the pre-trained model can be found in the paper. We ask what are their transparency goals. For each goal, what provided information in the documentation they used, and what additional information they requested. Based on that, we derive design implication to support these goals. We have this big table in the paper that I hope you will read in detail. In the next few slides, I'll walk through them at a relatively high level. The first goal is to understand the model well enough to be able to perform divergent convergent design thinking, to be able to generate many potential ideas and eliminate ones that are risky to user or delivering less benefits. This convergence stage requires designer to have a comprehensive understanding of model limitation, then translate them to potential harms specific to their design and their users. For example, Participants find information about the intended and unintended use in the documentation useful. They also requested additional information about the general characteristic of model output, such as the distribution of length and linguistic properties, to anticipate how users would perceive and react to the outputs. A second goal is to create conditional designs, that is, different design for different inputs, outputs, or different user scenario, to be able to mitigate AI's varying impact. For example, in this design, P3 considered only applying the model to long inputs, blocking outputs that contain sensitive content, and creating a different design for users who share many articles in a row. This goal gave rise to participants' prominent need to understand what factors can vary model behavior. Importantly, they care not only what varies model performance, but also many design-specific output characteristics, such as output length and coherence, and also API performance. Participants wanted to discover many factors and test factors based on user scenarios they could think of. To do so, they requested additional information about the training data, disaggregated ad evaluation, and explanations. A third goal is to provide transparency to end user, especially to expose limitation and potential harms. This often requires participants to translate information in the documentation to effective UI features. This goal also highlights that an AI product cannot be truly transparent if the designers themselves do not have a good understanding of the model. Designers' last goal is to be able to negotiate and collaborate with the team to advocate for users. A good understanding of model limitation and how it can be improved, such as customizability, can empower designers to better engage with the engineers. Their comments also reviewed two additional roles that model documentation can serve for product team collaboration. One is as common reference and boundary object. The other is to help designers gain AI literacy, for which some participants expressed desires for some level of technical information, such as the algorithm and training data. Overall, our study demonstrates the utility of documentation for supporting design ideation, but also points out many gaps, calling for supporting understanding model limitations specific to a designer's use case, input data, questions, and a hypothesis through model interrogation. We suggest a few directions for future work to develop tools to support designers' model interrogation. One is to support example-based interrogation, but in a more principled fashion. This could mean to allow designers to create or customize input dataset, guide them to explore the input-output spaces, engage in failure-oriented interrogation, such as discovering what kinds of input can lead to risky outputs. A second direction is to support disaggregated evaluation model to inform conditional design. Different from conventional disaggregated evaluation, designers can benefit from defining evaluation metrics specific to UX impact and exploring factors based on different user scenarios. Lastly, we hope our study provides some inspiration for tools that integrate model transparency support and design prototyping. I want to end this presentation by highlighting the point that designers can and should play a more central role in responsible AI practice, especially in the age of pre-trained model, including GPT. They're best positioned to ideate on whether, where, and how to use this model because they're trained to bridge user needs and technical affordance. With this kind of training, they can also translate technical limitation to risk and potential harm to user to be able to avoid and mitigate them. Participant design also illustrates a broad range of UX tools that designer can bring for RAI by creating interaction-level intervention, such as putting guardrails on model input and output, providing transparency to end users, and supporting user agency. With that, I'd like to conclude the talk, and thank you for watching.